We would now like to welcome our next speaker, Nikhil Bhandari. He has over 19 years of technical and people management experience with a track record of successful project delivery of high quality products. He is an engineering leader at Agio. Nikhil would be speaking on Road to Full Stack Quality Engineering Journey. To know more about him and to see his video interview, please check out the link below. Over to you, Nikhil.
Right.
Nikhil,
Thank
while
you.
you set up, let our audience know that you are an engineering leader that comes with 20 plus years of experience in the industry in quality engineering, test automation, tool development, and DevOps. And you have done your engineering bachelor's of engineering in computer science, and also have completed executive management program. So welcome on board, and I think we look forward to your session. Nikhil, over to you. Thank you.
Thank you, Namita. Thank you, Harpreet. Hello, everyone. A very good afternoon to everyone. All right. Let me share my screen and then we'll get started. Is
You can
my
see your
screen
screen.
perfect?
Yeah, we can.
All right. Great. So thanks for the great introduction. So the topic for today is around full stack quality engineering. It's an overloaded term used everywhere. I'm trying to simplify it and probably give you my perspective and how it helped me in my career so far, the kind of work that I have done and kind of problems that I have solved. All right. So, okay, a little bit about me. My work experience currently, I'm working with Agio, taking care of Agio business and seller platform. I'm assistant vice president of QA and DevOps there. And I've worked in my prior experiences, worked on insurance, payment, finance, and e-commerce and telecom domains. Take care of the DevOps, infrastructure, release management, and also quality engineering and automation. Some of my interests are around cricket, solving Sudoku. I ensure that at least one Sudoku is solved per day. And then I collect stamps and coins and currencies of different countries. All right. So what is our goal? What are we trying to do, right? As an engineering or as a quality engineering side of it, we want the single line of code which a developer writes can go to production. All the required quality gates that we have defined, it meets that, and also it works as expected, right? And why we need to do that? We need to have a faster go-to-market strategy so that we are ahead of our competition. We provide the great customer experience. The software that your customers are using are reliable, and it works with multiple configuration. In today's world, it has to work in multiple time zones, geographies, multiple the different device types and different OS types and various combinations of that. And how do we achieve that is doing a lot of automation. I think Seema talked about in the previous session. Automation at every level, which is more faster, more repetitive, more reliable. No one expects you not to fail, but you fail fast, you fail early, and use that learning back into your the entire process to get you started so that you are improving based on your learnings, right? And having that feedback loop of whatever you understood about your usage of your product or the thing that you worked on, how it is getting used and how do you improve that process so that you're better than what you were yesterday. I'm sure everyone would have seen this multiple times and everyone would have been at different stages of their journey in an agile development life cycle, right? The key point that I want to highlight here is the continuous feedback at every stage, right? So whatever you learned, you apply back, right? So that's what, and you cover the full stack. It's not only my job to just do the testing, and I don't care about how it is working in production, right? The idea is to you have an you are a you're responsible for quality from the teams will play a different role, but as a full stack you need to understand what language, code, and everything has been written, how it's getting deployed, what infra is being used, who is my customer base, how are they using it, so that you can apply the both sides of the technology as well as the customer, getting into the customer shoes, and bring that stitch together and define the entire testing, your testing processes, right? The infinite loop, everyone have seen it multiple times. There is no beginning, there is no end. You just keep improving on what you've done yesterday. You keep writing the code, keep testing it, deploying it in production, keep adding the new feature based on the requirements, based on the feedback that you get from your customers, and the process continues, right? So in the first step, you will never be, you'll not be giving everything what customer needs. In agile world, it's an incremental approach, but it's not only incremental. You also learn from customers. Sometimes the idea is customer may not be giving you the right information. They may ask you hundreds of things, but once they start using your product, right, they may come back, no, this is not what I asked for, I need slight change, right? So that's what agile is all about. And how quickly you deliver, your velocity, your capacity to get those changes into your cycle, so that you can deliver faster, deliver quickly to the customer, and get their feedback and apply that feedback in your system again to make it improve better is important, right? So a lot of things on the shift left side, a lot of things on the shift right side, and we'll deep dive into each of it. Right, a little zoom out picture, or maybe a zoom in picture of the continuous quality, right? And it is applicable at every level, right from you define your coding guidelines, your check styles, your the kind of unit testing, the code coverage, a lot of third-party integration. How do you mock them in lower environments, and how do you test them when it gets into the environment for the QA? How is your infrastructure set up, right? You don't want to be having a separate infrastructure setup for your QA environment versus how it is in production. If one is on the cloud and other one is on premises infrastructure, you're not really getting into customer shoes and testing it out. When your deployment happens, how quickly you can verify whether whatever the deployment is supposed to happen with all the different configurations of production with your different proxies and ports and everything, it's working fine. And how are you monitoring your usage of your product, so that you put some techniques around it, saying that before your customer finds out any issue, you will hear back by doing your synthetic monitoring side of it, right? Infra is one part where there is a separate team which will monitor if my infra goes down. But from an application perspective, you also need to have insights on, is a particular service, your infra, the service might be up, but probably not ready to take any request, right? So how do you identify those? And we'll talk about it in detail. Right, I mean, the idea is a new code. Every time a new code gets developed, build is deployed, a build is created, it's deployed and in production, right? So a lot of things on the shift left, little bit on the shift right, but yeah, it's a combination which will achieve the entire full stack for you, right? So what happens in the shift left part of it, right? So when a developer starts writing a code, right, you define your processes such a way that your code reviews are robust. Lot of insights from the code is identified early in the cycle, from the security perspective, from scanning perspective, right? From a performance perspective. So the static code analysis will give you a lot of insights on your static code, in terms of any performance issues. Are you using certain array or variables which are not getting used? You're unnecessarily allocating memory which is not getting used later, right? Your internationalization, if your product supposed to work on various geographies, and are you putting an English like text, right? You should be using the resource bundle. So these are some of the quick checks which can be done early in the cycle, And once you define a process around it and a quality gate around it, it's easy to identify, fix it early so that you don't end up spending good amount of time later point of time once it get deployed to production, right? In today's world, a lot of build versus buy, right? Not a lot of things that you want to build. You use a lot of dependencies, you use a lot of libraries and all the containers in today's microservices world. You want to ensure that because of certain dependency which has a vulnerability, your product should not be vulnerable, right? What happened with App Dynamics, right? You don't want to do that. Packaging, right? I mean, your secrets, right? I mean, yeah, everyone knows what happened with Uber, right? All their secrets were shared at some location, right? So you want to ensure that your packaging has to happen such a way that there's nothing exposed as part of the production deployment, right? And your application, along with your infrastructure, is secure with your configurations, right? Most of the secrets are stored in the configuration, and believe me, we use all the best practices in the world. We should have a secrets manager. There are multiple solutions available, but when you go on the ground reality, they are still stored in a text format, in a configuration file, right? So all this static analysis around security and performance will be able to identify and pinpoint those issues. It scans everything, and the rules are defined by individual teams, right? There are certain set of guidelines which comes as part of those tooling, but you can have your own set of rules. You can define them in a XML or a rule-based system, and then you can put that as part of your static code analysis, right? Along with the functional testing, there are a lot of other things that needs to be handled, right? One is on the scaling and performance, the security part of it, the disaster recovery or the failure recovery, right? So in today's world, based on your geographic location, you always have a DR system, the disaster recovery system, right? So if one of some services goes down, how do you ensure that your DR comes up, and then because of that DR could be in a different geographic location, it should not add latency, or it is functioning as it's supposed to work, right? When the deployment happen, how quickly you do a deployment verification test, and all the synthetic testing we talked about, right? So various types of verification that needs to be done along with the functional test. Very important thing, shift right. Different terminologies being used. I'm using shift right for this, but the idea is whatever the functional side, whatever the performance side, the security side, you have tested that, you're ready, you have done your deployment in the production. What happens next, right? You can do a lot of testing on production before you roll out to the customers. And I think Seema in her previous topic she covered about in the dark launching, the A/B testing, and the feature toggles, right? And I'm going to have some more points on that. But when your production deployment happens, do you do periodic heartbeat testing of your infrastructure and application? Do you have your health check APIs which you're constantly monitoring, right, in terms of how your service is behaving, right? Do you have proper logging and alerting mechanism as part of your deployment strategy, right? So that you collect information, and that information is fed, used by various set of people, by engineering team, by QA team, by product team, in terms of how your product is getting used. QA team will use it for applying their risk-based testing, right? When I say risk-based testing, you don't have enough time. You found certain things and you have to deploy that because of certain government guidelines or some business priorities, or there are dependent systems which are dependent on you, and you have to go live so that they can start integration, right? That time it will come in picture that if I cover this 80% of my workflows, I'm probably 90% or 95% risk is covered. Rest 5% is probably not that much used in production, right? That no much traffic comes around that, right? So and then probably use that as an application for the automation, right? When you want to start your automation, sometimes you're just starting from scratch. I don't have any automation. Where do I start? Of course, I categorized my P0s, my P1s, and my P2s, my priorities. but those are before I launch my product into the production, right? And those are given by probably your product and the business teams. But when you launch it in production, you get more insights from the real-time insights from your customer in terms of how they are using your product, right? Which type of mobile devices, which platforms, which browser versions, right? And you can use that as part of your automation strategy, that out of this, say 500 numbers, if I cover this 100, I'm going to get good coverage. These are my top 10 devices, which is going to give me probably 80% of coverage. So when I launch any new feature, I'm just reducing my risk by 80% by testing on these 10 devices. That 80 to 100% is always challenging. The effort that you would have put in the 80%, 0 to 80, you would have to put an extra double effort making that 80 to 100, right? So of course you take those decisions based on that. Monitoring, right? I mean, monitoring your production infrastructure when you need to scale out, when you scale up, right? Based on the patterns that you see from your, the kind of events which gets triggered, which gets monitored as, when the customers start using any specific time in a day, any specific day in a month, or any specific month in a year, what kind of events which trigger more traffic, right? And you be planning more from scaling the infrastructure. Synthetic monitoring we talked about, and we have done that, and probably I'll share a couple of examples as well that we have done. It could be an integration with your New Relics or App Dynamics or Dynatrace kind of monitoring tools, where they have an integration point where you can integrate your API calls or your rest assured test or your Selenium test, right? What you're trying to do is you're trying to mimic how customer uses your product, right? Directly in the production. Of course, it requires a lot of support from your development team. So what we did is we created a test user with certain pattern, and we told that to the business team that please start ignoring if you get this kind of pattern in your reports, so that all the numbers that you talked about should not the test account should not be part of those business reports, right? And then you create the test account, the demo user, and then you mimic the way you identify your top 10 workflows. We identified in our case the top 10 workflows that a customer uses, right from login to do a checkout, make the payment, and all of them, right? And then you mimic that, automate that, and then integrate that with your monitoring tool. You don't need a monitoring tool also for that. We can do that using, if there are API calls, we can do that using Postman and Newman. We can integrate the command line. It can run in an automated way, either through your CI/CD or like a batch job. And spitting out that information to log files. And in the log files with those patterns, we created a alerting dashboard. And this test run every 15 minutes. So from the dashboard, and we've created a threshold. From that threshold, it was done in Splunk. So from that threshold, if you start getting errors out every, if you miss that threshold number, the alert will send out to the entire team. And we identify that some of the services are going wrong here, right? So a lot of things can be done on the synthetic monitoring side. DR, I just mentioned about, right? The system should be restored back, right? On the DR side, on the disaster recovery side, right? But from your testing perspective also, it's very important that one of the services goes down and it is in a different region or a different data center. You need to ensure that there is enough timeouts, right? You don't want to enter get a timeout, right? Because it's the latency will increase, right? Where is your DR? Where is your database, right? Your database, if it's in a different zone, right? And your entire application, because of application services, move to a DR, you need to make sure that that piece is also tested when you are doing your DR testing. Right. Feature toggle flags, I think Seema also talked about in the previous topic, right? You should be able to modify your system without doing a deployment of the code. And in today's world, we deploy a lot of things. Sometimes we are dependent on other systems and they are not ready. But when they are ready, you should not have a separate deployment to change your configuration. You just enable the flag. But from a QA side, it is very important that you test your feature with flags, without flags, or with a partial enablement of some of the features during the flags, right? So that you don't need a separate deployment. I mean, and that is very critical in today's world. Fault tolerance, right? If any of the service goes down, and if you're using your mobile app, the app should not crash, right? I mean, ability to do a lot of chaos testing, where you identify the bottleneck, your application should gracefully exit, right? That is critical. There has to be a robustness, there has to be a failover. You identify what happens, you increase your load balancing thresholds in the server so that they can keep monitoring, and keep serving with the existing nodes that you have. Pipeline, yes. I mean, this is the typical pipeline. Probably with my previous experiences, I've come up with, right? We talked about some of them. I mean, there has to be certain things that needs to be done as soon as you do you write a single line of code, and then it goes to multiple quality checks and each and every layer in the pipeline, right? And everything in automated, including your rollbacks. You need to test your rollback testing as well. You need to have your rollbacks so that, and you need to have a strategy around rollback. What happens if for my DB, right? It needs to be backward compatible. Right. So you need to have a rollback strategy if partial versus full. From an automation perspective, right, we talked about on the left side, the development. This is your test automation part and the production insights, right? You get a lot of production insights, logs and monitoring. Your failed customer interaction, we call FCIs, right? I mean, all the 5xx errors, right? And how you can generate that in your lower environment. In what cases you get those 5xx errors? What happens when the 5xx happens, right? How do you figure it out? Your mostly used features, right? Your workflows, your response times, right? Your crashes and your business metrics, right? I think the middle part, I don't have to explain. Most of them are from the testing background. How you keep your framework abstraction and your test automation suite, and then how do you ensure that there are all the components which are talking to each other. You don't have to end up putting a lot of effort in getting the metrics out of all your test automation. It should be easily available for you to figure it out, what passed, what failed, how many times did I run the test, did I run it with the right configuration and everything, and how my tests are extensible. Different maturity model, production analysis, talked about chaos engineering. Test data plays a very important role. I think I have a slide on that as well. Most of the places that I have worked at, some of the incident in production happened just because we did not have the right test data in our lower environment. We could not replicate that, the set of relationship of that data in our lower environments. We could not do it. And the test impact analysis, if you're changing a particular code in a service, where all the impact it happens, right? And you need to have that impact analysis or the dependent system metrics, right? So as a QA engineer, you need to have a clear understanding of your architecture and the service contracts and how the workflow happens, right? One service calling to another service, UI calling to set of services, right? So it needs to happen that. Test data, very critical. There's no generic solution, but I think you need to work with your infosec, the security teams, the infosec security teams, where they will tell you which is PII, which is personally identifying information that you cannot replicate in the lower environment, right? But you should have a masking logic and get the production data, segment it out, get certain small segments so that on that you can create a multiple test data in the lower environments. And believe me, this is one of the key areas of most of the issues that we found in the production, right? And sometimes it happened the developer also started developing certain features considering that this is how the data would be, but then we went to production and then it failed considering we did not consider the multiple hierarchy or the tree that the data could go through. I think in my previous session in the track for SEMA covered Drac launching and A/B testing and canary testing, right? It's just that adding new features and not letting user know that you have added a new feature and observing how they interact with the system, and sometimes slowly increasing the feature list to certain set of users, right? And A/B testing is giving to different parts of the same implementation and see where you get more traction, right? Which variants you get more traction. Yeah, I want to spend some time here, right? I mean, the different abilities that you need to have for your full stack engineering, what you call full stack quality engineering, right? Testability aspect, right? You need to always ask that question to the developer, that, how are we going to test it? Do we need to test it at a unit level, integration level, at an end-to-end level, right? I mean, and you need to have a testability. And if you do not get the right answer, that how I am going to test this particular code that you have developed, you should push for it, that there has to be, you need to ask them to develop certain utilities which will help you to, mimic that, right? Accessibility, I mean, based on your accessibility, which country you're launching your product, you need to have certain accessibility compliance, right? Interoperability, very critical. In today's world, people will start on mobile and then leave to and move to browser, and then again move to probably a browser on a TV, right? So your product has to be operable everywhere, right? I mean, it has to be interoperable. It has to work in multiple set of devices, right? From a different screen sizes, different configuration, different platforms, right? And you need to use the data from production, to use data from your own previous experiences to come up with an interoperability strategy, right? Reliable, how often do you see you are able to use your system continuously, right? That's very, very key. Observability, when any incident happens in the production, how quickly you can identify which component has failed, right? By just looking at certain set of data, right? So from a black box perspective, you don't have to go through each individual logs and figure it out to trace that which component did not receive the required information, or it did not pass the required information to the next system, right? So observability has to be given at that level, so that identify the issue, so that you can fix the issue and later try to find out a root cause and put a permanent fix there. Scalability, yes, you need to identify where your system has to scale, which days in a year, which part where it requires a scaling. Even if your system scales and you have a payment gateway, and if they are not able to scale, then the entire system will fail, right? So it's not only you, all your dependent system, all your integrations needs to be scalable.
Quick time check.
Okay.
We are left with just 2 to 3 minutes more.
Perfect. Yeah, I'll just cover that. So on a feedback loop, right, we talked about voice of customer, production incident, production alerts, social media feedback, and review analytics. Put everything together, you will get a lot of insights on is there any issue with the production, right? Listen to your voice of customer calls, right? Work with your support team, get that information on a monthly basis. We do that review every month, look at what customers are saying about the product, and then we use that as part of our production as part of our backlog grooming, right? Put those points. Application is slow, application is not working the way it's supposed to be, right? All this information that you can get a lot of insights from the feedback loops. Health metrics, health metrics is across engineering, from production, business metrics, and all of them. And as a QA engineer, as a SDET engineer, you need to have access to everything, right? That is very critical. And I want to just wrap it up. Sorry, I was just rushing in the last minute, but yep. Thank you so much for listening to me. Thank you, GTR, for giving me this opportunity to present and talk about on this topic. Thank you so much. Thank you, Aditya.
Thank you, Aditya. We'd like to take one question that has come from the audience, from Archana. What tools and technologies should a full stack QA know? Or maybe in particular, how that person can transition to become a full stack QA.
Right. So I have one slide, which is just an example of what are the different tools, right? And as a full stack, it's just that curiosity you need to have to understand what my developer is using for managing my say databases queries, right? I mean, keeping my database configuration like Liquibase, right? So all of them have that curiosity to understand, and you'll find bunch of tools. This is just one list, right? Try to identify an area which you can automate. become more lazy, that you don't want to repeat the same manual step again and again, right? And try to use that as an automation so that you can focus, you keep focusing on the core things by ensuring that the business as usual things work as expected.
Thank you, Nikhil, for your response. There is one more question that we have from Dushyant. He wants to know, so full stack testing also includes operational bit of it. So is it kind of a test on? So that's just
Right, absolutely. You can configure, you can, different terminologies that you can use. In today's world, more and more work is, kind of shrinking together, and then only set of people are doing, everything is required. Right? There is no separate DevOps, Tech Ops, Prod Ops, or Release Ops, and all of them. Right. So I think it's all combined together, and you will, as a test engineer, you will grow when you understand how your production, the deployment happens, how your infrastructure is managed, and that will help you to figure it out what in the lower environments you should test so that it will work in production. Your goal should be how it works in production, right? Whatever I'm testing, it should work in production. So you will find all the ways to ensure that it works in production.
Thank you, Nikhil. Namita, over to you. I think these were the questions that we wanted to take.
Yes, ma'am.
Okay.
Thank you, Nikhil.